This is a class video for Friday, December 11th. So today I went over some announcements and reminders. Then we did not do a double replacement, but we did a review problem and an intro to acids and bases. And we presented the Stoic worksheet problems. And we did a Unit 4 practice assessment. That's a Google form and it's on Google Classroom. Monday, we will have the Unit 4 quest, and it will cover all the material from 1123 to 1211, except for titration. And you should also take pictures and write observations for the copper mine, and the AP Classroom questions on Unit 4 are due Monday as well. That will be counted as an assessment grade, but you're welcome to use your notes and collaborate with other people on that assignment. Oh, we answered this question. It was a silly question, but nice to think about. So with the copper mine, you should take a picture each day of the copper mine, and you will attach pictures to the Google Classroom assignment right here. So let me show what that looks like, and also you'll write down your observations on the observation sheet. You have to make a copy and attach to Google Classroom assignment. And make sure to label your copper mine and keep it in a safe place, because the copper 2 sulfate is poisonous. We'll talk about the actual reaction in next week. So the copper mining lab procedure and observations. This assignment looks like this. And if you take a look here, you'll need to take a picture and attach to that assignment right there. But you also put in the date and the time and take some written observations for each day that you take a picture. And then this assignment is due on December 22nd. So between now and then, take 7 days of observations, attach the pictures, and fill in your observation sheet. I also reminded people that there's this optional science fair proposal assignment. So this is a completely optional assignment, and the grade on this proposal can replace a test grade either in second quarter or third quarter. If this is something that you want to take on, this proposal is due January 19th. We can be a little bit flexible about that deadline. And then if you want to try to participate in the Region 4 Fair or MSEF, see me, and we just have to go through a registration process on Z Fairs. Qualification for ISEF is through Region 4 Fair if that's something that you're interested in. Another thing, I sent an email about this university study, this AP Teach study. Again, this is an optional thing, but if your parents do not wish you to get an offer to take a practice test and do a research study, then they should let me know, and let me know by next week. And I will not send you emails about those practice exams. There is a Mass Insight mock exam registration. At some point, I will ask you to register for the mock exam, which will be in March. And obviously, it's too far off to know anything, but we'd like you to just register and get on that list. So then we went and we did a pair deck, and we started talking about this problem, as it's an old FRQ. And so I'll just go through the answers to these. So here, an appropriate observation that provides evidence of a chemical reaction between these two compounds, that would be the formation of a precipitate. So that seeing a precipitate form is evidence that a chemical reaction has occurred. Next, we will calculate the moles of each reactant. So we have 0.150 grams of PbNO3 solid. In order to find the moles, we would divide by the molar mass of the compound. And this is 331.22 grams per mole. And we got 0.00045 moles of PbNO3 taken twice. And then for our, let me label that. And then for our sodium iodide, we just need to change this to liters, our milliliters to liters, and multiply our volume by our molarity, which is moles per liter. Liters cancels out, and we get 0.0125 moles of sodium iodide. And the rest of this problem I actually go over in the previous, in the December 10th class video. So I will not continue on, but you can go and take a look at that the previous day's class video for the rest of this problem. So I go through all of these parts and then also talk about this, which particle diagram is the correct one. It is this one right here. So if you go through that previous video, it is at the end of class, December 10th's class video. Then we briefly talked about acid-base theory, and I was able to do this with some students, but the other half of the class didn't get it. So this Bronsted-Lowry acid-base theory is the theory that we'll be using for acids and bases in this class. Bronsted-Lowry acids are substances that donate H+ ions. And H+ is called a proton because without the electron, all that hydrogen ion is just a proton. So acids are considered proton donors. On the other hand, Bronsted-Lowry bases are substances that accept protons, so they're called proton acceptors. So you can see how the proton is transferred here. The H+ goes to the base. The base accepts the H+, and then here we can see that the acid, the Bronsted-Lowry acid, becomes the conjugate base. The Bronsted-Lowry base becomes the conjugate acid. And again, I go through this all in the end of the previous day's class videos, so you can go and look at that for these examples. Same with these two examples are on the previous day's video. And then here we have a couple of acid-base neutralizations. So the only type of neutralization that we'll be dealing with in this chapter is the strong acid, strong base neutralization, which forms water and a salt. So here, if we do the double replacement, we get H2O and NaCl. And we can see that this will be aqueous, this is aqueous, H2O is a liquid, NaCl is aqueous. So the net ionic is the formation of water. So the net is the H+ aqueous plus the OH- aqueous, and we form H2O liquid. And that will be the net ionic equation for all strong acid, strong base neutralizations. You can see the same net ionic with this example right here. So HNO3, again, do the double replacement. We will get water plus calcium nitrate. Nitrates are soluble. Water is a liquid. This is a strong base. It is aqueous. Strong acid is aqueous. And so we just need to balance here. We need a 2 here and a 2 here. And you can see again that here we've got the H+ and the OH combining to form water. So again, here for the second reaction, the net ionic is again, H plus OH minus forms H2O liquid. Same net ionic for all strong acid, strong base neutralizations. And we just said this again, net ionic is always this. Always for strong acid plus strong base. So then once we finished that short pair deck, we went and presented the stoichiometry worksheet problems, and I've posted the answer key to those problems on Google Classroom, and we had people present those. And then once we were done with that, I had people go into breakout rooms and do this practice assessment.